Hey everybody, this is WireDogSec back with another video for you guys. Today's video, we are inside of TryHackMe. This is the Cybersecurity 101 learning path. This is the web hacking module. This is the SQL fundamentals. Learn how to perform basic SQL queries to retrieve and manage data in a database. Hopefully, you're all having an awesome day today and ready to learn something. Now, let's go ahead and dive into it. Task 1, Introduction. Cybersecurity is a broad topic that covers a wide range of subjects, but few of those are as ubiquitous as databases. Whether you're working on securing a web application, working in a SOC, and using a SIEM, configuring user authentication / access control, or using malware analysis / threat detection, the list goes on, you will in some way be relying on databases. For example, on the offensive side of security, it can help us better understand SQL vulnerabilities such as SQL injections and create queries that help us tamper or retrieve data within a compromised device. On the other side, on the defensive side, it can help us navigate through database and find suspicious activity or relevant information. It can also help us better protect a service by implementing restrictions when needed. Because databases are ubiquitous, it is important to understand them, and this room will be your first step in that direction. We'll go through the basics of databases, covering key terms, concepts, and different types before getting to grips with SQL. Room prerequisites. This room has been written specifically for beginners. Because of this, users with little to no IT experience will be able to follow this room without the need to complete any of our material beforehand. However, having the Linux fundamentals down would prove helpful. So check that out if you are interested in Linux fundamentals. Learning objectives, understand what databases are, as well as key terms and concepts, the different types of databases, what SQL is, and be able to use SQL CRUD operations, be able to use SQL clauses operations, be able to use SQL operations, or understand and be able to use SQL operations, operators, and functions. Teach me the basics of SQL. Okay. Task number 2, Databases 101. Introducing databases. Okay, you've been told just how important they are. Now it's time to understand what they are in the first place. As mentioned in the introduction, databases are so ubiquitous that you very likely interact with systems that are using them. Databases are an organized collection of structured information or data that is easily accessible and can be manipulated or analyzed. That data can take many forms, such as user authentication data, such as usernames and passwords, which are stored and checked against when authenticating into an application or site, like TryHackMe, for example. User-generated data on social media, like Instagram and Facebook, where data such as user posts, comments, likes, etc., are collected and stored, as well as information such as watch history, which is stored by streaming services such as Netflix and used to generate recommendations. I'm sure you get the point. Databases are used extensively and can contain many different things. It's not just a massive scale businesses that uses databases. Smaller scale businesses, when setting up, will almost certainly have to configure a database to store their data. Speaking of kinds of databases, let's take a look now at what those are, different types of databases. Now it makes sense that something is used by so many and for relatively so long that there would be multiple types of implementations. There are quite a few different types of databases that can be built, but for this introduction room, we are going to focus on two primary types: relational database, aka SQL, and non-relational databases, aka NoSQL. So you got relational databases, table-based, non-relational databases, key value graph, wide column, document. Relational databases stored structured data, meaning the data inserted into the database follows a structure. For example, the data collected on a user consists of first underscore name, last underscore name, email underscore address, username, and password. When a new user joins, an entry is made in the database following the structure. This structured data is stored in rows and columns in a table, all of which will be covered shortly. Relationships can be made between two or more tables, for example, user in order underscore history, hence the term relational databases. Non-relational databases. Instead of storing data the above way, store data in a non-tabular format. For example, if documents are being scanned, which can contain varying types and quantities of data, and are stored in a database that calls for a non-tabular format. Here's an example of what that might look like. And this does look like a bit like JSON here. But yeah, you can see you got the ID up here, name, date of birth, occupation, steps taken. In terms of what databases should be chosen, it always comes down to the context in which the database is going to be used. Relational databases are often used when the data being stored is reliably going to be received in a consistent format where accuracy is important, such as when processing e-commerce transactions. Non-relational databases, on the other hand, are better used when the data being received can vary greatly in its format, but need to be collected and organized in the same place, such as social media platforms collecting user-generated content, tables, rows, and columns. Now that we've defined the two primary types of databases, we'll focus on relational databases. We'll start by explaining tables, rows, and columns. All data stored in a relational database will be stored in a table. For example, a collection of books in stock at a bookstore might be stored in a table named books. You can see the whole thing here is the table. You got the rows here, all right, going um, this way, and you got the columns going up and down. When creating this table, you would need to define what pieces of information are needed to define a book record, for example, ID, name, and published underscore date. These would then be your columns. When these columns are being defined, you would also define what data type this column should contain. If an attempt is made to insert a record into a database where the data does not match, it is rejected. The data types that can be defined can be or can vary depending on what database you are using, but the core data types used by all, including strings, a collection of words, characters, integers, numbers, floats, slash, decimals, numbers with a decimal point, and times and dates. Once a table has been created with the columns defined, the first record would be inserted into the database. For example, a book named Android Security Internals with an ID of 1 and a publication date of 2014-10-14. Once inserted, this record would be represented as a row, primary and foreign keys. Once a table has been defined and populated, more data may need to be stored. For instance, we want to create a table named authors that stores the authors of the books sold in the store. Here's a very clear example of a relationship. A book stored in the books table is written by an author stored in the authors table. If we want to query for a book in our story, but also have the author of that book return, our data would need to be related somehow. We do this with keys. There are two types of keys. Okay, and this is what we're talking about here. You got the primary keys and you have the foreign keys here. Primary key. A primary key is used to ensure that data collected in a certain column is unique. That is, there needs to be a way to identify each record stored in a table, a value unique to that record and is not repeated by any other record in that table. Think about matriculation numbers in a university. These are numbers assigned to a student, so they can be uniquely identified in records as sometimes students can have the same name. A column has to be chosen in each table as a primary key. In our example, ID would make the most sense as an ID has been uniquely created for each book, whereas books can have the same publication date or in rare cases book title. Note that there can only be one primary key column in a table. Foreign keys. A foreign key is a column or columns in a table that also exists in another table within the database and therefore provides a link between the two tables. In our example, think about adding an author ID field in our books table. This would then act as a foreign key because the author underscore ID in our books table corresponds to the ID column in the author table. Foreign keys are what allow the relationships between different tables and relational databases. Note that there can be more than one foreign key column in a table. Awesome. All right, question time. What type of database should you consider using if you are going to be storing going to be storing will vary greatly in its format. Well, non-relational database as discussed above. What type of database would you consider using if if the data you're storing will be reliable in a structured format? Well, relational database, like I said, SQL, right? And this one was NoSQL for the non-relational. That was that example. In our example, once a record of a book is inserted into our books table, it would be represented as a blank in that table. Well, that's going to be a row, as we discussed earlier. Which type of key provides a link from one table to another? Well, that's foreign key, right? It said that one doesn't have to be unique, right? Whereas primary key does. So that's going to be those. Task number 3, SQL, or SQL for short. What is SQL? Now, all of this theoretically sounds great, but in practice, how do databases work? How would you go and make your first table and populate it with data? What would you use? Databases are usually controlled using a database management system, a DBMS for short, serving as an interface between the end user and the database. A DBMS is a software program that allows users to retrieve, update, and manage the data being stored. Some examples of DBMSs include MySQL, MongoDB, Oracle Database, and MariaDB, which is database. And you can take a look here at this graphic. The interaction between the end user and the database can be done using SQL, which is structured query language. SQL is a programming language that can be used to query, define, and manipulate data stored in a relational database. The benefits of SQL and relational databases. SQL is almost as ubiquitous as databases themselves, and for good reason. Here are some of the benefits that come with learning and using to use SQL. It's fast. Relational databases, aka those that SQL is used for, can return massive batches of data almost instantaneously due to how little storage space is used and high processing speeds. Easy to learn. Unlike many programming languages, SQL is written in plain English, making it much easier to pick up. The highly readable nature of the language means users can concentrate on learning the functions and syntax. Reliable. As mentioned above, relational databases can guarantee a level of accuracy when it comes to data by defining a strict structure into which data sets must fall in order to be inserted. Flexible. SQL provides all kinds of capabilities when it comes to querying a database. This allows users to perform vast data analysis tasks very efficiently. All right, hands-on time. Now that we covered what SQL is, it's time to get hands-on and start using it yourself. Click the green start button, which you've already have the machine running here. Split view is already activated. Once the machine has finished booting up, open the terminal and run the following command. So let's go ahead and do that. My SQL-U for username is going to be root, and then -p for the password. Once entered for the password, enter TryHackMe. Okay, so let's go ahead and type the password in. All right, looks like we're connected. Output should look as follows, and that's exactly what we are seeing over here. With that covered, you are ready to start using and learning SQL. What serves as an interface between a database and an end user? Well, that's the DBMS, Database Management System, right, as we saw up here. And then the last one was what query language can be used to interact with a relational database? SQL. That's what it uses. It's a relational database, okay? Now let's go ahead and continue to task number 4, database and table statements. Time to learn. Now the fun part. It's time to start learning SQL and how to use it to interact with databases. In this task, we're going to start by learning to use database and table statements. After all, it's these statements we need to initially create our databases slash tables and get started. Database statements. Create database. If a new database is needed, the first step you would take is to create it. This can be done in SQL using the create database statement. This would be done using the following syntax, and this is what it looks like: create and then database and then the database name. All right, so we're going to create a database called THM bookmarket DB. So I'm just going to copy and paste this over. Okay, looks good. Show databases. So let's go ahead and do that. Okay, there we go. There's quite a few of them in there, it looks like. Ah, there's the flag for something. And the return list, you should see the database you have just created and some databases that are included by default. MySQL, information underscore scheme, etc., which are used for various purposes that enable MySQL to function. Also present are various tables needed for this lesson. Use database. Once a database is created, you can or you may want to interact with it. Before you can interact with it, we need to tell MySQL which database we would like to interact with so it knows which database to run subsequent queries against. To set the database we have just created as the active database, we would run the use statement as follows. Make sure to run this on your machine. All right, so let's go ahead and do that here. Okay, now we're using it here. Drop database. Once a database is no longer needed, maybe it was created for test purposes or is no longer required, it can be removed using the drop statement. To remove a database, we would use the following statement syntax, although in our case, we want to keep our database, so no need to run this one yourself. So if you want to play around with it, I guess you can create a test database in it real quick and then use the drop statement on it to delete it. Now, obviously, in like production environment, you want to be careful of what you're doing with this drop because you can cause a lot of damage with it. Table statements. Now that you can create, list, use, and remove databases, it's time to examine how we would populate those databases with tables and interact with those tables. Create table. Follow the logic of the database statements. Creating tables also uses a create statement. Once a database is active, you can run the use statement on it. A table can be created within it using the following syntax. Let's go ahead and just copy and paste this over. Well, let's wait because we're probably gonna get into it down here. But anyway, this is what the syntax looks like. Create table, table name, column 1, 2, 3, data type, etc., etc. As you can see, there's a little more involved here. In the databases 101 task, we covered how and when a table is created. It must be created or decided what columns will make up a record in that table, as well as what data type is expected to be contained within that column. That is what is represented by the syntax here. In our example, there are 3 example columns, but SQL supports many over 1,000. Let's try populating our THM book market database with a table using the following statement. Create table book inventory, and then inside of here, we're going to have book ID, int, auto increment, primary key, book name, var, char, not null, publication date, and date. So let's go ahead and do this here. And go ahead and paste this down here. All right, let's go ahead and continue on. This statement will create the book inventory with 3 columns: book ID, name, publication date. Book ID is an int, which is integer, as it should only ever be a number. Auto increment is present, meaning the first book inserted would be assigned book ID 1. The second book inserted would be assigned book ID 2, and so on. Finally, book ID is set as primary key, as it will be the way we uniquely identify a book record in our table, and a primary must be present in the table. A book name has the data type varchar 255, meaning it can variable characters, text, numbers, punctuation, and a limit of 255 characters to set, and not null, meaning it cannot be empty. So if someone tried to insert a record into the table, but the book name was empty, it would be rejected. Publication date is set as the data type date. Show tables. Just as with just as we can list databases using a show statement, we can also list the tables in our current active database, the database on which we last used the use statement. Run the following command, and you should see the table we have just created. So let's go ahead and do that. Show tables. Seems pretty straightforward so far. There we go. Book inventory. Describe. If we want to know what columns are contained within a table and their data type, we can just describe them using describe command, which can also be abbreviated to desc or DESC. Describe the table you have just created using the following command. So describe book inventory. So let's go ahead and do that. Okay, there we go. This will give you a detailed view of the table like so, and that's exactly what we can see here. Alter. Once you have created a table, there may come a time when you need for the data set changes and you need to alter the table. This can be done using the alter statement. Let's now imagine that we have decided that we actually want to have a column in our book inventory that has the page count for each book. Add this to our table. Use the following statement: alter table book inventory and add page count int. So let's go ahead and do that here. Okay. The alter statement can be used to make changes to a table, such as renaming columns, changing the data type in a column, or removing a column. Drop. Similar to removing a database, you can also remove tables using the drop statement. We don't need to do this, but the syntax you would use for this would be drop and then table and then a table name. So like I said, you can create a test table in here and then try this drop if you want to. But we're going to continue on. Using the statement you've just learned to list all databases, it should reveal a database with a flag for a name. What is it? As we saw that earlier. Okay, if we scroll back up here, we can see that here. So that's going to be that one. And the list of available databases, you should see the task for DB database. Set this as your active database and list all tables in this database. What is the flag present there? So let's go ahead and try that. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. All right, now we don't need to type in database there. You just type in use and then it'll change it. So now we need to go to the show tables. So I'm just going to copy and paste. Okay, there we go. So there's the other flag there. And we're going to go to task number 5, CRUD operations. CRUD stands for create, read, update, and delete, which are considered the basic operations in any system that manages data. Let's explore all these different operations when working with MySQL. In the next two tasks, we will be using the books table that is part of the database THM books. We can access it with the statement use THM books, create open or operation insert. The create operation will create the new records in a table. In MySQL, this can be achieved by using the statement insert into as shown below. Alright, so they have insert into books, ID name, published date, description, values, etc. Query okay. As observed, the insert into statement specifies a table, in this case, books, where you can add a new record. And let's just let's get into this database real quick. Okay, I already forgot what the command was. Let me just up arrow. I think it's just maybe it's just show database. Yeah. There. Okay. Show databases with an S. Okay. So we need to get into this one here. So I'm gonna copy and paste. All right. Now we're in there. Now we're gonna do this insert like so. Okay, it says duplicate entry, but okay. Maybe it was already in there. But let's continue on. The columns ID, name, published date, and description are the records in the table. In this example, a new record with an ID of 1, a name of Android security internals, a published date of 2014, etc., and a description stating Android security internals provides a complete understanding of the security internals of Android devices was added. Note, this operation already exists in the database, so there's no need to run the query. I wish I had said that before I read through all this, but it is what it is. Read operation select. The read operation, as the name suggests, is used to read and retrieve information from a table. We can fetch a column or all columns from a table with the select statement as shown in the next example. Select all from books. Okay, and let's just go ahead and do this here. Okay, there we go. The above output select statement is followed by a asterisk or star symbol indicating that all columns should be retrieved, followed by the from clause in the table name, in this case, books. If we want to select a specific column like name and description, we should specify them instead of the star symbol as shown below. So you can say select name and description from books. Okay, that's the ones we're going to be taking a look at here instead of everything. Update operation, update. The update operation modifies an existing record within a table, and the statement update can be used for this. Also, if you want to try this out, we could just go ahead and copy this, paste this over to see what it looks like. Okay, same thing here with update books, and it says update books set description equals an in-depth guide to Android security, yada yada yada, where ID equals 1. Okay, and it says the update statement specifies the table, in this case books, and then we can use set followed by the column name we will update. The where clause specifies which row to update when the clause is met, in this case the one with ID 1. Delete operation, delete. The delete operation removes records from a table. We can achieve this with the delete statement. There's no need to run the query. Deleting this entry will affect the rest of the examples in this upcoming task, so let's not do that. But this is what it looks like. Delete row from books where ID equals 1. Above, we can observe the delete statement followed by the from clause, which allows us to specify the table where the record will be removed, in this case books, followed by the where clause that indicates that it should be the one where the ID is 1. Summary. In summary, CRUD operations results are fundamental for data operations and when interacting with databases. The statements associated with them are listed below. You have the create insert statement adds a new record to the table. You have read, which is the select statement, retrieves record from the table. Update statement modifies existing data in the table. Delete statement removes record from the table. These operations enable us to effectively manage and manipulate data within a database. All right, question time. Using the tools DB database, what is the name of the tool in the hacking tools table that can be used to perform man-to-man attacks on wireless networks? And go ahead and try that out and then come back to the video. Also, this one says using the tools database, what is the shared category of both USB Rubber Ducky and Bash Bunny? So go ahead and try those out and then come back to the video and we will continue on. Okay, so let's go ahead and take a look here. They want us to take a look at this tools database, and that's exactly what we're doing here. Use, then the name of the database, which is tools database, okay? Tables and tools, hacking tools is what we want to take a look at, all right? So we did a show tables to list out the tables, and then we are going to take a look at everything inside of this particular table. So select all from hacking tools, all right? And don't forget that semicolon. And we can see everything listed out in here. All right, and it says man in the middle attack on wireless networks. Well, if we take a look at ID3 here, which is a Wi-Fi pineapple, Wi-Fi hacking, a device used to perform man in the middle attacks on wireless networks. The next one says, what's the category that's shared with USB Rubber Ducky and Bash Bunny? So let's go ahead and take a look at those. So we have a category here for Rubber Ducky, USB attacks, and the next one is Bash Bunny down here, and you can see that USB attacks is going to be our answer. So let's continue to task number 6, clauses. A clause is a part of a statement that specifies the criteria of the data being manipulated, usually by an initial statement. Clauses can help us define the type of data and how it should be retrieved or sorted. In previous tasks, we already used some clauses such as from that is used to specify the table we are accessing with our statement and where, which specifies which records should be used. This task will focus on other clauses, distinct, group by, order by, and having. Distinct clause. The distinct clause is used to avoid duplicate records when doing a query returning only unique values. Let's use a query select all from books and observe the results below. All right, so let's go ahead and follow along here on our screen. And that's right, I need to go back to the other database and let's see. I forgot the name of it already. So we need to do show databases. There we go. And we need to use the THM books. All right, now it should work. Oops. This is what I was looking for here. All right, there we go. The query's output displays all the content of the table books, and the record ethical hacking is displayed twice. Let's perform the query again, but this time using the distinct clause. So let's go ahead and do that here. Awesome, there we go. The output shows that only 5 rows are returned and just one instance of the ethical hacking record is displayed. Group by clause. The group by clause aggregates data from multiple records and groups the query results in the columns. This can be helpful for aggregating functions. All right. So it's select name count from books group by. So in this example, the records on the book table are regrouped by the result of the count function. We already know that ethical hacking is listed twice, so the total count is 2, placed at the end since it is grouped by count. All right, so let's go ahead and do that here. Order by clause. The order by clause can be used to sort the records returned by a query in ascending or descending order using functions like ASC and DESC. I'm just going to say ask and desk. Can help us help us to accomplish that as shown below in the next two examples. So let's go ahead and try that out. For ascending, it's going to be our first one here. There we go. And then the next one is going to be descending order. Okay, there we go here. Awesome. We can observe the difference when sorting by ascending order by using ask and descending order by using desk, both using the published date as a reference. So yeah, if you look here and then take a look at the other one up here. All right. Having clause. The having clause is used with other clauses to filter groups or results of records based on a condition. In the case of group by, it evaluates the condition to true or false. Unlike the where clause, having filters the results after aggregation is performed. And let's take a look here on our side. In the example above, we can observe that the query returns the books with the names that contain the word hack and the proper count, as we learned before. Awesome. That's some good stuff here. Question time. Using the tools database, what is the total number of distinct categories in the hacking tools table? Using the tools database again, what is the first tool by name in ascending order from the hacking tools table? Using the tools database, what is the first tool by name in ascending order from the hacking tools database? So go ahead and try that out yourself, then come back to the video and we will continue on. Okay, let's go ahead and take a look here. The first one, we need to find the total number of distinct categories in the hacking tools. Remember, we have to use uh, this use command and then the name of the database to switch back over to this tools database. So don't forget that. And we are selecting using distinct and then category from hacking tools. All right, because it said we need to find the categories that are distinct, and the number of them is going to be 6. So 1, 2, 3, 4, 5, 6. All right, you can see that here, 6 rows. And next one says that we need to sort by ascending, and the next one is descending. And then what's the name of the tools and the um, that come up first? So the first one is going to be ascending. So select star from hacking tools, order by name, ascending, or ask. And you can see bash bunny is the first one that comes up here, and then you do the opposite using desk here or descending. And you can see Wi-Fi pineapple is the one that comes up here for the first one. So there's that. And then task number 7, we're going to talk about operators. When working with SQL and dealing with logic and comparisons, operators are our way to filter and manipulate data effectively. Understanding these operators will help us to create more precise and powerful queries. In the next two tasks, we will be using books table that is part of the database THM books 2. We can access it with the following statement. So let's go ahead and do that here. We're switching databases once again. And here we go. Okay, now we're using it. Logical operators. These operators test the truth of a condition and return a Boolean value of true or false. Let's explore some of these operators next. Like operator. The like operator is commonly used in conjunction with clauses like where in order to filter for specific patterns within a column. Let's continue using our database to query an example of its usage. So select star from books where description like guide. So let's go ahead and do that here. Okay. The query above returns a list of records from the books filtered, but the ones using the where clause that contains the word guide by using the like operator. And you can see that here, in-depth guide, guide, guide. Okay. And operator. The and operator uses multiple conditions within a query and returns true if all of them are true. So select star from books where category equals offensive security and name equals bug bounty bootcamp, which you should check that book out. It's awesome. And let's go ahead and paste this in. Okay, there we go. That's the only one in here. The query above returns the book with the name Bug Bounty Bootcamp, which is under the category Offensive Security. The OR operator. The OR operator combines multiple conditions within queries and returns true if at least one of the conditions are true. Okay, so we take a look here. Select star from books where name like Android or name like iOS. And here we go. You can see the same thing here. You got Android, etc., etc. The query above returns books whose names include either Android or iOS. The not operator. The not operator reverses the value of a Boolean operator, allowing us to exclude a specific condition. So select star from books where not description like guide. So it's not going to include anything that has guide in it. And let's go ahead and paste this over. There we go. So the query above returns results where the description does not contain the word guide. Between operator. The between operator allows us to test if a value exists within a defined range. So select star from books where ID between 2 and 4. So let's go ahead and do that here. Okay, let's try this again. Awesome. So we got 2, 3, and 4. The query above returns books whose ID is between 2 and 4. Comparison operators. The comparison operators are used to compare values and check if they meet specified criteria. Equal to operator. The equal operator compares two expressions and determines if they are equal, or can check if a value matches another one in a specific column. So select star from books where name equal designing secure software. All right, so it's going to find that anything that matches that. So the name above returns the book with the exact name, designing secure software. Okay, there you go. The not equal to operator. The not equal operator compares expressions and tests if they are not equal. It also checks if a value differs from the one within the column. So select star from books where category not equal to offensive security. So it's going to return everything except anything that has that information in it. The query above returns books except those whose query or category is offensive security. All right. Here we go. So we got Android and designing secure software. Less than operator. The less than operator compares if the expression with a given value is lesser than the provided one. So select star from books where published date is less than 2020-1-1. So there we go there. Error message. I forgot the S in there. Let's try that again. All right, there we go. The query above returns books that were published before January 1st, 2020. Greater than operator compares if the expression with a given value is greater than the provided one, so the opposite of what we just did. Okay, there you go. The query above returns books published after January 1st, 2020. What's less than or equal to and greater than or equal to operators? The less than or equal to operator compares if the expression with a given value is less than or equal to the value or the provided one. On the other hand, the greater than or equal operator compares if the expression with a given value is greater than or equal to the provided one. Let's observe some examples below here. So let's take a look at these. Okay, there's the first one. And then it says the query above returns books published on or before November 15th, 2021. And then here's the other one. Okay. And it says the query above returns books that were published on or after January 2nd, 2021. Awesome. Question time. Using the tools database, which tool falls under the multi-tool category and is useful for pen testers and geeks? Using the tools database, what is the category? of tools with an amount greater than or equal to 300 using the tools database. Which tool falls under the network intelligence category with a amount less than 100? So go ahead and try to figure that out yourself, then come out to the video and we will continue on. Let's go ahead and take a look here. We need to find the tool that falls under multi-tool category and is useful for pen testers and geeks. So our first thing to do is to take a look at everything inside this database, which is what I did. You can do whichever approach you want to take, but this is what I did. Select all from hacking tools. And if you scroll down here, you can see what I'm looking for here. So we need to select all from hacking tools where category like multi-tool. Okay, so we're looking for anything that has that multi-tool in there. And then it's the result, this flipper 0 here. And it says a portable multi-tool for pen testers and geeks in a tool-like form. So there we go there. I guess you could search off a description too if you wanted to. But next one says that the category tools with an amount greater than or equal to 300. So what we want to do is select all from hacking tools where amount is greater than or equal to 300. And this is what we got right here. And we take a look at the category and it says RFID cloning. So that's going to be what we're looking for here. Next one says which tool falls under network intelligence category with an amount less than 100. So we have to do multiple things here. All right. So if we scroll down here, we can see that I'm selecting all from hacking tools where category equals to network intelligence. Okay. So that's what we're looking for, the first item. And the second item is less than 100. So it's going to be land turtle. I did less than or equal to, but I got the same answer. So if you want to fix that, you can just use less than instead of less than or equals to. You get the same thing. So there you go there. Task number 8, functions. And let's see what we are cooking with here. When working with data, functions can help us streamline queries and operations and manipulate data. Let's explore some of these functions next. String functions. String functions perform operations on a string, returning a value associated with it. Concat function. This function is used to add two or more strings together. It is useful to combine text from different columns. You can see an example here. Select concat name is a type of category book as book info from books, and this is what the results are here. All right. Now, I'm assuming they want us to switch back to that database. So I think it was, I keep forgetting the name. So show databases. I guess this is good practices if you keep forgetting like me. So show databases. Okay. And then we want to use, it doesn't specify which one. Let's just wait. Maybe they'll say it down here. This query concatenates the name and category columns for or from the books table into a single name book info. Actually, I think it did say that we need to use this one here. So let's go ahead and do that. If anything, we just switch back to the other books databases anyway. So let's go ahead and copy and paste this over here. Yep. Okay. Group underscore concat function. This function can help us to concatenate data from multiple rows into one field. Let's explore an example of this usage here. Select category, group concatenate, name, separator, which is going to be this comma here in a space, as books from books, group by category. So let's go and plug this in. There we go. And let's see, the query above groups the books by category and concatenates the titles of the books within each category into a single string. Substring function. This function will retrieve a substring from a string within a query. Starting at a determined position, the length of the substring can be specified. So we got select substring, published date, 1/4 as published year from books. There we go. And let's see, we get the same results here. Okay, good to go here. In the query above, we can observe how it extracts the first 4 characters from the published date column and stores them in the published year column. Length function. This function returns the number of characters in a string. This includes spaces and punctuation. We can find an example below. So let's go ahead and plug this one in as well. There we go. As we can observe, the query calculates the length of the string within the name column and stores it in a column named length. Aggregate functions. These functions aggregate the value of multiple rows within one specified criteria in the query, it can combine multiple values into one result. Count function. This function returns the number of records within an expression as the example below shows. So let's go ahead and do that here. All right, 5. The query above counts the total number of rows in the books table. The result is 5 as there are 5 books in the books table and it's stored in the total books column. Sum function. The function sums all values not null of a determined column. There's no need to execute this query. This is just for example purposes. So this is what it would look like if we were to execute this somewhere. The query above calculates the total sum of the price column. The result provides the aggregate price of all books in the column price. Max function. This function calculates the maximum value within a provided column in an expression. So if we go ahead and take a look here, there's a lot to take in here. The query above retrieves the latest publication maximum value date from the books table. The results 2021 12/21 is stored in the column latest book. Minimum function. The function calculates the minimum value within a provided column in an expression. Okay, there we go, 2014. The query above retrieves the earliest publication minimum value date from the books table. The value 2014 10/14 is stored in the earliest book column. All right, question time. Using the tools database, what is the tool with the longest name based on character length? What is the total sum of all tools? And what are the tool names where the amount does not end in 0? And group the tools by concatenated, or tool names concatenated by the ampersand or and symbol here. So go ahead and try to figure that out yourself, then come back to the video and we will continue on. Let's go ahead and take a quick look here. First one here. Tool with the longest name based on character length. Well, if we go in, take a look at our query, we're selecting length. So we're using length here in the name as length, and then comma, name from Hacking Tools, order by length in descending order. And there you go, rubber ducky, answer there. Next one, you're going to be using the sum, as we learned above about that. Okay, so sum amount as total price from Hacking Tools. There's total price. And the last one is going to be using this group underscore concat. Name separator is going to be an, as it said right there. As tools from Hacking Tool, where amount 10, and then not equals to 0. So the only ones that come back are going to be this flipper 0 and the icopy dash XS. So there you go for those. Task number 9, conclusion. So let's wrap this up. Congratulations on completing the SQL fundamentals room. This room has hopefully taught you the importance of databases in computing with so many uses or use cases which we frequently interact with in our day-to-day lives. Learning the fundamentals is a must if you want to pursue a career in cybersecurity. To round things off, let's summarize everything that was covered in this room. So we talked about databases, which are collections of organized data or information that are easily accessible and can be manipulated or analyzed. The two primary types of databases are relational databases used to store structured data and non-relational databases used to store data in a non-tabular format. Relational databases are made up of tables, columns, and rows. Primary keys can ensure a record is unique within a table, and foreign keys can allow for a relationship connection to be made between two or more tables. SQL is an easy-to-learn programming language that can be used to interact with relational databases. Database and table statements can be used to create / manipulate databases and tables. CRUD operations, insert, select, update, and delete, can be used to manage data in a database. In SQL, we can use clauses to define how data should be retrieved, filtered, stored, or sorted, or grouped. The efficient use of operators and functions can help us filter and manipulate data in SQL. That wraps up this room. Click the button below to complete the room. All right, so hopefully you all enjoyed this video. If you found it educational, found it of value, hit that like button. Subscribe to the channel if you're new here. Hit that notification bell so you know every time I post a new video. As always, thank you all for watching my video. Have a nice day, and I will see you later.